The paper of the day is Cubrick, a scalable distributed MOLAP database for fast analytics. Cubrick is a distributed in-memory multi-dimensional OLAP database designed to handle real-time analytics on large dynamic datasets. It supports sub-second OLAP operations like slice and dice, roll-up, and drill down over terabytes of data. Cubrick's architecture is built around a strictly multi-dimensional data model which includes dimensions hierarchies, and metrics. Data is stored in containers called bricks, which are unordered and sparse, allowing for high data ingestion rates and indexed access through every dimension. The system is particularly suited for dynamic workloads such as real-time data streams and does not rely on pre-calculations, instead executing queries on the fly using MPP architectures. Here are the key contributions: innovative data model, high performance, scalability, and flexibility. In terms of innovative data model, Cubrick introduces a strictly multidimensional data model that efficiently handles dynamic datasets without relying on pre-aggregations. The system achieves high data ingestion rates and supports fast query execution by chunking data into bricks and leveraging MPP architectures. Cubrick can scale horizontally and supports interactive query execution using a subset of SQL called CQL. Here are the highlights. Real-time analytics. Cubrick enables real-time data analysis by executing OLAP operations over dynamic datasets, making it ideal for environments like Facebook where timely insights are crucial. Efficient data storage. Data is stored in a sparse and unordered fashion within bricks, allowing for efficient data ingestion and immediate query availability without the need for reordering or index updates. Scalable architectures. The system's distributed architecture allows it to handle large datasets and scale smoothly with experimental results, showing query execution over billions of cells in milliseconds. Putting some notable quotes from the paper. The first is Cubrick works especially well in highly dynamic systems such as real-time data streams. No reordering or index update is required at load time, making ingested data immediately available to queries. Unlike traditional data cubes, Cubrick does not rely on any pre-calculations. Rather, it distributes the data and executes queries on the fly leveraging MPP architectures. In terms of paper score, this gets 9 out of 10. Cubrick presents a significant advancement in the field of real-time analytics on large datasets. Its innovative approach to data storage and query execution, combined with its scalability and performance, makes it a valuable tool for dynamic data environments. The paper is well structured and provides comprehensive insights into systems architecture and capabilities.